Good morning. Today we are going to cover section 9.2, the unit circle and its functions. So take the time to copy down your title and your essential question. How do you evaluate trigonometric functions using the unit circle? Go and paste your cutout and we'll start once you are ready. Definitions of trigonometric functions in the unit circle. Let t be a real number. So therefore your angle is going to be a real number. And let x, y be the point of the unit circle corresponding to t. You can use these coordinates to define the 6 trigonometric functions of t. Now, one of the things that you want to think about is that the point, that's going to be a coordinate, x and y. So therefore, if we place a perpendicular line towards the x-axis, this is going to be a right angle. Therefore, this is your x value, and that is your y value. Correct? The sine of the angle t is going to be the y value. The cosine of the angle t will be your x value, and the tangent will be y over x, the same way that you learned this in geometry. We know that sine and cosecant are reciprocals of each other, so therefore to find the cosecant of t will be 1 over y. We know that cosine and secant are reciprocals of each other, so therefore to find the secant of t, or theta, which is your angle, is 1 over x. Tangent and cotangent are inverses of each other, are the reciprocals of each other. So therefore, the cotangent of the angle, either theta or t, it's x over y. Well, we don't want the denominator to be 0. Otherwise, it'll be undefined. Now, trigonometric values of special triangles. Now, back in geometry, you learn 2 special triangles. If you remember this from geometry, if we have a right triangle and you learn your 30, 60, 90 degree angle, correct? Where this was 60, this is 30, it's your smaller angle. This is 60, and this is 90. And the way that you learned it was this is 2. This was square root of 3, and the smallest one was 1, correct? You also learned your 45, 45, 90. If I make a angle here, a triangle, a right triangle, where this is 45 degrees, and this is also 45 degrees. The way that you learned it back in geometry, do you remember? Correct. This is 2, this is square root of 2, and this is square root of 2. That they have the same measurement. Now, in trigonometry, or in algebra 2, once we use a unit circle, we are going to do it slightly different. Now, you can always refer this back to special problems where you need to find one side. Then you can just do 1, 2, square root of 3, where 2 is your longer side and 1 is your smaller side. But once we go into a unit circle, first we're going to do a 30-degree angle. Now, to do a 30-degree angle, we're going to divide this in 3 sections, so therefore I need 2 dashes evenly spaced. And actually, I place it closer to your x-axis and to the y-axis, so I can see the lengths a little more clearly and distinguish between both of them. So therefore, this will be my 30-degree triangle. And this is 30 degrees. But instead of being 2, square root of 3, and 1, this is going to be a unit circle, so I'm going to divide each one by 2. So therefore, 2 divided by 2 is 1. Your shorter side will be 1/2, and your longer side will be the square of 3/2. Your hypotenuse is always going to be 1 because we are going to be talking about a unit circle, 1 unit. Now, for your, this is your 30 degrees. This is going to be your 45, and this is going to be your 60. So let's go through the 60 next. I'll place 2 dashes evenly spaced, and that'll be 30, this will be 60. We'll make a right triangle. We'll make it a perpendicular line towards the x-axis. And this is a 60-degree angle. Once again, we have two sides. We have a shorter side versus the longer side. So therefore, we are still using your 30, 60, 90 that you learn in geometry, but now we have a unit circle, so therefore your radius is 1. So your hypotenuse will be 1. Your shorter side is going to be 1/2. Your longer side will be the square of 3/2. So that is something that you need to memorize. Shorter side is 1/2. Longer side is square of 3/2. And on a 45-degree angle, so halfway mark, in geometry, you learn 2, square root of 2, and square root of 2, where both sides are equal. If I divide everything by 2, 2 divided by 2 is 1, so we have a unit circle. The hypotenuse is 1. And both sides are square root of 2 divided by 2. Something to keep in mind with the 30-degree angle and a 60-degree angle is that shorter side is 1/2, longer side is square root of 3/2. On a 45-degree angle, we know that both of them are congruent and both of them are square root of 2/2. So that is something that you need to memorize. 45 is square root of 2/2. 30-degree, shorter side is 1/2, longer side square root of 3/2. 60 degrees, shorter side was 1/2, longer side is the square root of 3/2. So let's go through example number 1. A, B, and C. Evaluate the trigonometric function. So first we're going to make an x and y axis, and we're going to make a smaller one. So we're just going to make a 3x3, something small that we can just quickly reference your angle. Now you must do this on the homework. I need to be able to see your graph. Now, pi over 3. Remember, your pi over 3 is your 60 degrees. So I'm going to divide this in 3 sections by placing 2 dashes. So pi over 3 is up here. And I'm going to make my right triangle towards the x-axis. And I'm looking for the sign. So I need to think, is my sign my x or my y? My sign is the y value. And I need to think, is the y value the shorter side or the longer side? Your y value is your longer side, which is the square of 3/2. So therefore, the sine of pi over 3 is equal to square root of 3/2. Cosine of pi over 6. I'm going to draw my x and y axis as a quick 3x3. I'll locate where is pi over 6. So pi over 6 is your 30 degrees. So I'll place my 2 dashes evenly spaced. And I should place them a little closer to the x-axis and the y-axis. So when I make my triangle, I can easily distinguish which is my longer side or my shorter side. Now, cosine, is that your x or your y? Cosine is your x value. So therefore, your x value is that your shorter side or your longer side compared to your y value. That is the longer side. So therefore, that'll be equal to square root of 3 divided by 2. Easy as that. Cosine of 45 degrees, I'm going to make my x and y axis. I'll make it quick 3 by 3. "45" is your halfway mark. And then I need to think cosine. Is that your x or your y value? Cosine is your x value. And your x value is what is the length. Remember, we're talking about the length of this side, which on the 45 is square root of 2 over 2. D, E, and F. Go and copy it down. And let's go and make 3 by 3s. The tangent of 30 degrees. Let's go and look at where is 30 degrees located. So therefore, 30 degrees is, I'm going to place 2 dashes evenly spaced, a little closer to the x and y axis. And 30 degrees is located here. I'm making my angle, and I'm going to make a right triangle. Tangent. Tangent is your x or your y. Tangent is y over x, correct? Is y over x. So therefore, what is the length of your y and what is the length of your x? Your y is 1/2, is the shorter side. Your x is the longer side, so it'll be square root of 3 over 2. So therefore, tangent is y over x, so it'll be 1/2 over the square root of 3 over 2. I'm going to change my division to multiplication. It will be 1/2 multiplied by the reciprocal. It will be 2 over square root of 3. My 2's cancel. So therefore, it will be 1 over square root of 3. And I need to be able to rationalize my denominator. Square root of 3 is an irrational number, and I do not want irrational numbers on my denominator. So I'm going to rationalize my denominator. And that gives me square root of 3 divided by 3. So tangent is equal to square root of 3 divided by 3. Now, usually for tangents, we don't want to do this over and over again. So I do memorize my tangent of 30, my tangent of 45, and my tangent of 60. Now let me do tangent of 60 first, and then I'll do tangent of 45. Tangent of 30 versus tangent of 60. The way I memorize it is that I know that both of them are going to be square root of 3. Now, which is smaller, 30 degrees or 60? 30 degrees is smaller, so therefore that one I divide by 3. So therefore tangent of 60 is square root of 3, and the tangent of 45 is going to be the y over the x, and because they're equal to each other, it's going to be 1. So you do want to be able to memorize those. And I'll go over this again later on today. Sine of 45. Let me make my x and y. I'm going to go ahead and draw my angle. 45 degrees is my halfway mark. And sine is that your x or your y. Sine is your y value. And the y value on a 45-degree angle is the square of 2 over 2. Tangent of pi over 3. I'm going to make my x and y axis. So where is pi over 3? Pi over 3 is your 60 degree. 30, 60. So whenever you're making your 30 or 60, I do want to be able to see those two dashes. Now, this is 60 degrees, and I can go through the whole process where I can do the y over the x, or I can just memorize it on the left-hand side. And you do want to be able to memorize it because as we do the inverse, you'll have to know them. But for this one, I know that the y is the square of 3 over 2 is the longer side. My x is my shorter side. And therefore, tangent is y over x. Therefore, that is the y is the square of 3 over 2 over my x, which is 1/2. I'm going to change it to the reciprocal. 2 over 1. My 2's cancel. So therefore, that is equal to the square of 3. Right? So it is best to be able to memorize that, okay, tangent of 30 versus tangent of 60. I know that they both are square of 3, and I just think, which is the smaller one? Square tangent of 30. So therefore, that one gets divided by 3. Example number 2. Go ahead and take the time to paste your callout, read through it, copy example number 2, and we'll continue once you are ready. Go ahead and pause it. So definition of definition of periodic function. A function is periodic if there exists a positive real number c such that. So if there's a value of c, that whenever you add c, the function will be the same as if you only had the t. So for all t in the domain of f, the smallest number c for which f is periodic is called period of f. So therefore, sine is periodic because if you have the value of 2 pi, every 2 pi is going to repeat, correct? If you go all the way around, you end up on the same location, so therefore, you can just take the sine of s, such as, for example, the sine of 5 pi over 4 plus 2 pi is equal to the sine of 9 pi over 4 if you add them together. And the sine of both angles are equal to the square of 2 over 2. Same thing the cosine. Every 2 pi repeats, so therefore cosine is periodic with a period of 2 pi. And we'll come back to this once we graph sine and cosine. So therefore, the cosine of pi over 3 plus 2 pi is equal to 7 pi over 3. So if you take the cosine of 7 pi over 3, it'll be the same as if you only take the cosine of pi over 3, which is 1/2. And for tangent, your period is pi, where n is any number, then the tangent of s plus any type of pi gives you just the tangent of s, such as the tangent of pi over 6 plus pi, which is 7 pi over 6, is the same thing as if you have only taken the value of the tangent of pi over 6, which is equal to the square of 3 over 3. So let's go through example number 2. Evaluate the following trig function. Now we know that this is bigger than 2 pi, correct? 13 pi over 6. We know that 12 pi over 6 is 2 pi. So therefore, I can rewrite it as the cosine of pi plus this is 12 pi over 6 is 2 pi. So how many more 6s do I need to get to 13? I need one more, correct? So therefore, the cosine of pi over 6 plus 2 pi should be the same as the cosine of pi over 6. So according to this, because this is periodic, if I evaluate the cosine of 13 pi over 6 is the same as evaluating the cosine of pi over 6. I can exclude the 2 pi. And now I'm going to make my x and y axis. That's a quick 3 by 3. Pi over 6 is my 30 degrees, so I'll place my 2 dashes. 30 degrees is here. And then I need to think, cosine, is that my x or my y? Cosine is my x value. And is that my longer side or my shorter side? That is the longer side, which is the square of 3 over 2. So therefore, the cosine of pi over 6 is the same as square of 3 over 2. So therefore, the cosine of 13 pi over 6 is the square of 3 over 2. The sine of 13 pi over 6 over 3. That means that the sine plus, I know that this is how many thirds? I want it to an improper fraction. So this is 3 goes into 13 4 times and 1/3. So therefore, that is 4 pi plus 1/3 of pi over 3 will give me 13 pi over 3. Do you agree? So therefore, I can evaluate the sine of pi over 3, and according to the definition above, that will be the same value because this is a multiple of 2 pi. Or if I want, I can actually take the time to rewrite it as they did above. And say plus 2 times 2 pi. And because that's a multiple of 2 pi, this will be the same as evaluating the sine of pi over 3. I'm going to make my x and y axis. And I'm going to evaluate the sine of pi over 3. Pi over 3 is my 60 degrees, so therefore it will be 30, 60. So therefore my angle will be up here. My sine, is that my x or my y? My sine is the y value. And is that the shorter side or the longer side? That is the longer side, which is the square of 3 over 2. So therefore, the sine of pi over 3 is equal to the square of 3 over 2. And that sine of 13 pi over 3 will be exactly the same, the square of 3 over 2. cosine of 9 pi over 4. I can rewrite the cosine, see what you get for this one, and then we can compare our answers. Correct. I can rewrite as a cosine of, I'm going to rewrite this as a mixed fraction. So 4 goes into 9 twice, and 1/4. Correct? So therefore, it will be plus 2 pi and plus 1/4. 1/4 pi. So therefore, this will be equivalent as the cosine of pi over 4. I'm going to make my x and y axis. 1/4 is here. Cosine, is that my x or my y? Cosine is your x, and what is the length of this side? On a 45 degree, or a pi over 4, both sides are the square of 2 over 2. So therefore, this is equal to the square of 2 over 2, and therefore this is exactly the same. Notice that also one of the things that you also need to think about is that 13 pi over 6 and pi over 6 are coterminal angles because they all land on the same location. 13 pi over 3 and pi over 3 are coterminal angles because they land on the same location, and the same thing is the case for 9 pi over 4 and pi over 4. So however you want to think about it, whether using the notation above or thinking about the coterminal angles, you get the same answer. Example number 3. Even and odd trigonometric functions. Go ahead and paste it, copy it down, and we'll start once you are ready. Go and pause it. So we talk about even and odd functions back in chapter 2. The cosine and secant, both of them are even functions. Remember that even functions, if you evaluate cosine of negative t, is equal to the cosine of t. And the same thing for secant. Sine and tangent, cosecant and cotangent are odd, which means that if you evaluate the sine of negative t, is equal to negative the sine of t. Same thing for tangent, cosecant, and cotangent. So therefore, if I need to be able to evaluate the cosine of negative pi over 6, because it's even, this will be the same as evaluating the cosine of pi over 6. And if we make an x and y axis, and for your homework, for whenever you have to evaluate, I do need to be able to see your x and y axis and your triangle being drawn. Pi over 6 is your 30 degrees, 30, 60. I'll make my quick. And cosine, is that your x or your y? Cosine is your x value. And is that your longer side or your shorter side? That'll be my longer side, so it'll be the square of 3 over 2. Sine, on the other hand, is an odd function, which means that when we evaluate the sine of pi over 6, that means that we're going to get the opposite, because it's an odd function. So therefore, I'm going to evaluate the sine of pi over 6 first. Now, once we move on to other sections, we're actually going to do a slightly different, but I do like to be able to go through the process and think about even and odd functions once again that we haven't done in a bit. So therefore, I'm going to evaluate the sine of pi over 6. Pi over 6 is here, 30, 60 is my 30-degree angle. And I know what you're thinking, can I just use this triangle? No, you must draw a new one. My sine, is that my x or my y? My sine is my y value. My y value is 1/2. So therefore, because it's a shorter size 1/2, and therefore will be negative. How about for cosine of negative pi over 4? Well, cosine is an even function, so therefore if I evaluate this, this will be the same as evaluating the cosine of pi over 4. It'll be exactly the same value. So therefore I'll place my x and y axis. Cosine of pi over 4. Pi over 4 is my 45-degree angle, my halfway mark. And cosine is my x or my y value. Cosine is my x value. And my x value is the square root of 2 over 2. And therefore, it'll be exactly the same. So that is even and odd functions. Now let's talk about quadrant angles. I need to evaluate, go and copy down A, B, C, and then I'll come back to D and F in a second. When I need to evaluate sine of pi over 2, you want to be able to place an x and y axis. And sine of pi over 2 is up here. So therefore, there's no triangle. And that is called a quadrant angle. So I'll place my on the left-hand side. We're going to use the location of the point. Remember, this is a unit circle. So therefore, this point is located at 1, 0. This point here is negative 1, 0. This point up here is 0, 1. And this point down here is 0, negative 1. So therefore, sine of pi over 2 is located up here. This will be 0, 1. And I need to think, is sine my x or my y value? Sine is my y value. And the y value is 1, because the length of this segment, my y, is 1. So therefore, this is equal to 1. Cosine of pi. Let me make my x and y axis. And yes, you do need to make your x and y axis on each of your problems. Cosine of pi. We know that pi is located over on this side. The location of that point is negative 1, 0. And I need to think, cosine, is that my x or my y? Cosine is your x, which is negative 1. Cosecant. We know that cosecant is the reciprocal of sine. So therefore, I'm going to place my x and y axis. I'm going to find sine, and then I'm going to take the reciprocal to find my cosecant. So therefore, cosecant of 3 pi over 2, that's 1, 1/2, 2/2, this is 3/2, is located here. The location of this point is 0, negative 1. The sine of 3 pi over 2, sine is my y value. So therefore, the y value is negative 1. Negative 1. I need to find the reciprocal of negative 1. Well, this is negative 1 over 1. The reciprocal is also negative 1. Correct? It's 1 over negative 1, which is negative 1. Now, for tangent of pi, let's go and make an x and y axis. pi is located here. The location of that point is -1, 0. Tangent is x or y? Well, tangent is y over x. The y value is 0. The x value is -1, which is 0. Tangent of pi over 2 is going to make your x and y axis. Pi over 2 is up here. The location of that point is 0, 1. Now tangent is y over x. And in this case, y is 0, y is 1, x is 0. 1 divided by 0 is undefined. Now, one of the things that you need to be able to remember and memorize for this class in PreCalculus is remember that we cover slopes back in Algebra 1. Actually, I have my notebook from Algebra 1 here. And when we cover slopes, we classified your slopes. Your slope is positive, negative, 0, and no slope or undefined. Now in calculus, you'll discover that your slope is actually your tangent. And therefore, whenever it's a horizontal line, at 0 or pi is a 0 slope. When it's a vertical line, it's undefined. So the same thing will happen here. If it's either 0 or pi, for tangent will be 0. For pi over 2 or 3 pi over 2, your tangent will be undefined. 0 slope, undefined. 0 slope, undefined. Undefined, 0 slope. Same thing from Algebra 1. Example number 5. Go ahead and place your card, copy it down, and we'll start once you are ready. So many times, depending on the way that books evaluate trig functions, they use something called reference angle. So we do need to cover just to be able to know the concept. Let theta be an angle in standard position. Its reference angle is the acute angle, denoted as theta low apostrophe, formed by the terminal of theta and the horizontal line. So let's go and draw the triangle. First, you need to be able to find the angle. Where's 210 degrees? I'll place my angle. I'm going to make it 4 by 4. So first, where is 210 degrees? Well, I know that this is 180. 30 more degrees is 210, so therefore I'm going to place my 2 dashes evenly spaced, or a little more towards the x and the y axis. So therefore, this is 210 degrees. Your reference angle is formed by the terminal side, which is this side, and the horizontal line, which is this side. So therefore, that is your reference angle here. So therefore, you want to go back to your closest angle. And so, okay, if this is 210 degrees, your closest x-axis, this is 210 degrees, and this is 180 degrees. So therefore, my reference angle is 30 degrees, correct. And notice that's a theta with an apostrophe. 4 pi over 3. Now I'll place my x and y axis. Just do a quick 4 by 4. Or 3 by 3 should be fine. Where is 4 pi over 3? Well, I know that this is pi, correct? And how many thirds are in pi? 3/3. How many more thirds do I need? One more third, which is your 60 degree. Now place two dashes. So therefore this will be 4 pi over 3, which is your 240 degrees. So this is 3/3, 4/3. You want to always go back to your closest x-axis, which therefore will be here. So what is the measurement of the angle? It's 60 degrees, but in radians. So therefore your reference angle, this is 3/3, 4/3. So I need to go back 1/3. So therefore be pi over 3. Remember that it's going to be always an acute angle, which is less than 90 degrees. 1/7. So let's go make an x and y axis. Where is 1.7 radians, not degrees, because it doesn't have a low degree sign. That means that this is going to be, this is radians. Well, we know that 1 radian is around here. The question is 1.7 before or after 90 degrees? So is it before or is it after? Where's 1.7 radians? Well, we know that this is pi over 2, correct? And we know that pi is 3.14 divided by 2. We know that 3 is 1.5 and 0.14 is 0.7. So this is 1.57. And if you have a calculator, you can actually just do the division, correct? If you want to do pi divided by 2, 1.57. So therefore it'll be after, correct? So it'll be right around here. This is 1.7 radians. Remember, your reference angles, you always have to go towards your closest x-axis. So you always want to go towards your horizontal line, which is your x-axis. So therefore I need to continue. How much more do I need to go to get to pi? You can say, well, pi is 3.14, so you can say 3.14 minus 1.7, which is 2.44, or 1.7. 3.14 minus 1.7, which is 1.44, or we can just say your reference angle is pi minus 1.7. So we actually have an exact answer. Go ahead and paste your next circle, and we are now using the arrow this time around. And we're going to label it. So we have 0 degrees, and we're going to use degrees, and we know the equivalency for radians. 0 degrees, we know the halfway mark is 180 degrees, all the way around is 360 degrees. Your halfway mark is 90 degrees, plus 90 is 180, plus 90 is 270 degrees. Then we're going to do your 45s, which is 45 degrees, plus 45 is 90, plus 45 is 135, plus 45 is 180, plus 45 is 225, plus 45 is 270, plus 45 is 315 degrees. Now your 30s. This is 30 degrees, plus 30 is 60, plus 30 is 90, plus 30 is 120 degrees, plus 30 is 150 degrees, 180, plus 30 is 210 degrees, plus 30 is 240 degrees, Plus 30 is 270, plus 30 is 300, plus 30 is 330, plus 30 is 360. Now, radians. This is 0 radians. All the way around is 2 pi. Halfway mark is pi. We know the halfway mark is pi divided by 2 is pi over 2. That's 1 half. 2 halves. This is 3 pi over 2. And this is 4 halves, which is 2 pi. Now your 45s is pi over 4, 1 4, 2 fours, 3 pi over 4. This is 4 fourths, which is 1 pi. This is 5 fourths, 6 fourths, 7 fourths, 8 fourths. Now your pi over 3s. This is 1/3. 2/3, 3/3, 4/3, 5/3, and 6/3, which is 2 pi. Now your pi over 6. 1/6, 2/6, 3/6, 4/6, 5/6, 6/6. This will be 7/6, 8/6, 9/6, 10/6, 11/6. And this is 12/6. Now, when we are dealing with pi over 6, now we're going to make our triangles. When we're dealing with pi over 6, we know that we have a shorter side versus a longer side. We know that the shorter side is 1/2, and the longer side is the square of 3 over 2. So let's write down on the left-hand side. Shorter side is 1/2. Longer side is equal to the square of 3 over 2. And whenever it's a 45-degree angle, both of them are the square of 2 over 2. So that is something that you need to memorize. So once you get to a 45-degree, we know that we are comparing both sides in the congruent, which is the square of 2 over 2. Now, once we get to a 60-degree, we are comparing the y versus the x, where your y value is your longer side, which will be square of 3 over 2, and this will be your shorter side, which will be 1/2. If we get to the 90-degree, we know that that is the coordinate of 0, 1, where your cosine will be your x, which is 0, and your sine will be your y, which is 1. And then we continue all around the circle. 120 degrees, we are comparing your y value versus your x value. Now, your y value is positive, and it's the longer side, which is square of 3 over 2. But because we're going to the left, that's going to be a negative 1/2, because that's your shorter side. Then we continue with the 45. Both sides are congruent, but now your y value is going to be positive, but your x value will be negative. On 150, or 5 pi over 6, your shorter side is 1/2 positive, and that'll be negative square of 3 over 2. 180 degrees, we're going to use the coordinates of the point, which is 1, 0. Negative 1, 0. So therefore your cosine is negative 1, your sine is 0. Once we get to 210, that'll be negative 1/2, and your cosine is negative square of 3 over 2. So for 210, your cosine is negative, and your sine is also negative. For 225 degrees, negative square of 2 over 2, and your cosine is also negative square of 2 over 2. for 240 degrees, your y value is your sine, which is negative square root of 3 over 2, longer side. Shorter side is negative 1/2 because it's going to the left. 270 degrees is 0, comma, negative 1. So your cosine is 0, your sine is negative 1/2. For 300 degrees, your cosine is positive 1/2, your sine is negative square root of 3 over 2. For 315 degrees, your cosine is square root of 2 over 2, your sine is negative square root of 2 over 2. And for 330 degrees, your cosine is the longer side, which is square root of 3 over 2, and your sine is your shorter side, but will be negative 1/2 because it's going down. And the last example for today. Find the trig values. Go ahead and copy it down, and we'll start once you're ready. I'm going to pause it. So now, for sine of 5 pi over 6, I'm going to make a quick 3 by 3. And first I need to be able to locate where's 5 pi over 6. Well, I know that this is 6 over 6, correct? So 1 will be 1/6 less. So I'll place my 2 dashes, and this will be 5 pi over 6. You need to be able to know where your angles are located. And now your sine, is that your x or your y? Your sine is your y value. So therefore the y value is here. Is that your longer side or your shorter side? That'll be your shorter side, which will be 1/2. It will be positive because it's going up. So therefore this is equal to 1/2. Cosine of 5 pi over 4. So cosine of 5 pi over 4, first I need to look at where is 5 pi over 4. So this is pi, and we're talking about fourths, so therefore this will be 4 over 4, which is 1 pi. And one more fourth gives you here, that'll be 5 pi over 4. Now I need to think, cosine, is that my x or my y? Cosine is my x. So therefore, we know that the length of a 45, both of them are congruent, which is square root of 2 over 2. But because we're going to the left, it will be negative square root of 2 over 2. So therefore, this is equal to negative square root of 2 over 2. The cosine of 5 pi over 4 is negative square root of 2 over 2. Cosine of 3 pi over 4. I'll make my x and y axis. Three pi over 4. Well, I know that I'm dealing with fourths. I know that this is pi. And I know that there are 4 over 4 in 1 pi. So therefore 3/4 will be 1/4 less, which will be located here. And cosine is my x value. And my x value is located here, which is square root of 2 over 2. But because I went to the left, it will be negative. So therefore, this is negative square root of 2 over 2. Easy as that. D, E, and F. Tangent of 4 pi over 3. I'm going to make my x and y axis. I first need to locate where is 4 pi over 3. Well, I'm dealing with thirds, and I know that this is pi. So there has to be 3/3. So So therefore, one more third, and I get to 4 pi over 3. Remember, your thirds are your 60 degrees, so they'll be over here. Place my 2 dashes. 4 pi over 3 will be located here, where is the same as 240 degrees. Make my right triangle. Now, I can go through the entire division, but I know that whenever is, let's write that down on the left. Tangent of 30 versus tangent of 60. They both are square root of 3. The smaller one gets divided by 3. So therefore, the tangent of this angle, which the reference angle is 60 degrees, is going to be square root of 3. The only thing that I need to be concerned about is whether it's positive or negative. The y value is negative, and the x value is negative, so therefore negative divided by negative will be a positive. Or if you want, you can go through the entire division. Negative square root of 3 over 2 divided by 1/2. But you do need to be able to memorize this for the next chapter. Tangent of 7 pi over 6. First, I need to be able to locate where is my angle. Seven pi over 6. Well, I'm dealing with sixes, and I know that this is 1 pi, so therefore this is 6 over 6. That means I need to do one more 6, which is my 30 degrees, which will be located here. And that's the 30-degree reference angle for tangent will be square root of 3 over 3. Positive or negative? Well, my y value is negative and my x value is negative, so therefore negative divided by negative will be a positive. And cosecant of 5 pi over 3, I need to evaluate the sine of 5 pi over 3 and then take the reciprocal. So I'm going to make my 3 by 3. Where is 5 pi over 3? Well, I'm dealing with thirds, correct? So I know that this is 1 pi. So therefore, there'll be 3 thirds. This is 2 pi. So therefore, this will be 6 pi over 3. Do you agree? So therefore, 5 thirds will be 1/3 less, which is your 60 degrees. Therefore, your angle will be here is the same as 330 degrees. Sine is your y value, and the y value is square root of 3 over 2. Is the longer side, and now it's going to be negative because it's going down. So therefore, this is negative 2 over square root of 3. And now I'm going to take the reciprocal, which is negative, I took the reciprocal away. This is negative square root of 3 over 2. Take the reciprocal, will be 2 over square root of 3. I'm going to rationalize it. So therefore, that will be negative 2 square root of 3 over 3. That is the cosecant of 5 pi over 3. This concludes the lesson for today. Have a great day, and I'll see you next time.